Hello and welcome back. This is a Math 050 video, and we're going to be talking about section 11.1, which is the introduction to factoring, the GCF, which is the greatest common factor, and then factor by grouping. Okay, so what we're going to be able to do is we're going to be able to find the greatest common factor, the GCF of monomials, and we're going to factor polynomials when the terms have a common factor and factoring out the greatest common factor. So let's talk about the GCF, okay? And let's talk about what this term factor means. Factor is a word for multiply. So factor, okay, means that we multiply, all right? And so, or we also use it as to write numbers as the product of two numbers, okay, of two numbers. All right, so what we're going to do here is kind of talk about the greatest common factor of some numbers here. So let's go ahead and talk about the greatest common factor of 20 and 30. And when I do that, I write out, 20, and then I put a colon here, and then I write out 30, okay, and put a colon there. Now what I do is I think about all the pairs of numbers that multiply to 20, okay? And so what I do is I'm going to write, okay, I've got the numbers 1 and 20, okay? I know I also have the numbers 2 and then 10 and then 4 and 5, okay? And so, 1 times 20 gives me 20, 2 times 10 gives me 20, 4 times 5, okay? Let's now do this for 30. So for 30, I know that 1 and 30 are two of them. I've got 2 and 15, and then I've got 3 and 10, and then I've got 5 and 6. So we have a lot of common factors here, but I'm looking for the one that's the pair of numbers that is the largest. Okay, and so the numbers 10 and 10 out of these two lists are my largest factors. Okay, so 10 and so this 10 and this 10. Okay, if I combine those, my greatest common factor is 10. So I'm just going to write out that my GCF is equal to 10. And that's my answer. All right. Okay, now let's take a look at the next one. The GCF of 180 and 420. Now this is going to be quite a few numbers here. So let's take a look at the numbers 180. And let's write out 420. All right, now this is a little bit harder because there's just a lot of numbers. So the first ones that I have, and the way that I do this to figure out what factors are there, first of all, I've got 1 and 180. Let's do this. Then I've got 2 and then 90. I've got 3 and 60. I've got 4 and 45. I've got 5 and 36. I've got 6 and 30. I've got a few more, I think, here too. Let's see, does 7 go into 180? No. I've got 9 and 20. Okay, so I'm going to put this 9 and 20 as well. And then I have 10 and 18. All right, and then the last one I've got is 12 and 15. And all I'm doing here is to find out these numbers, like if I want to see if 2 is a factor, then I take 180 and divide it by 2, and that gives me 90. Okay, now finding all the ones for 420 would be really, really, really daunting. So what I'm going to do is this. I'm going to start with a number that I think might work, and that's 180. So I'm going to take 420 and divide it by 180, and that doesn't give me an even number, okay? So that doesn't work. If I do 420, let's try 60, that'll work, and that's going to be 7, okay? So what I know is that, you know, along with like 1 and 420, what I want to figure out, I have 7 and then I have 60. Okay, now 60 was my third largest number here. Okay, I tried 180, I tried 90, and none of those worked. So what I have to just assume is that 60 is my greatest common factor. So instead of you guys going through and, you know, finding all of the factors for 420, you may want to start with your lower number, find one of the higher factors, and start dividing that out. So my greatest common factor for here, my GCF, would be 60. All right, and that's it. Okay. All right, let's take a look at this one of 30 and 77. Now, what I notice about this, let's take a look at the factors of 30 and the factors of 77. All right, the factors of 30 are going to give me 1, 2, 3, 5, 6, 10, 15, and then 30, okay? Now, if I find the factors of 77, this is a little bit trickier. 1 and 77, okay, are factors. I can't divide 77 by 2 because it's an odd number, but let's take a look at, let's just try 3, see if 3 works. I don't think it does. It doesn't. And the other numbers that I know for sure are 7 and 11, okay? And there are no other factors of 77. So my greatest common factor here is just 1. Okay, so my GCF is equal to 1, all right? And that's all we're doing. So we got to look for what's common in both of those groups. All right, so let's take a look at the next one. And so what I want to do is I want to find the greatest common factor of all of these terms, okay? Now, the interesting thing here is about that we are introducing a variable when we're doing these problems, all right? So I'm going to come through. The first thing I'm going to do is I'm going to list off all of the coefficients, so 15, negative 12, 27, and negative 3. So if I write all those out, I've got 15, negative 27, 12, and then negative 3. All right, so to find the common factor here, what I want to look for, I'm going to expand out all the factors. So for 15, I've got 1, 3, 5, and 15. For 27, I've got 1, 3, 9, and 27. For 12, I've got 1, 2, 3, 4, 6, and 12. And then for 3, I've got 1 and 3. Now, notice, you know, I didn't really account for the negative. When we're factoring these out, we kind of just disregard the negatives when it comes to that, just to find the greatest common factor. But when I look at this list, I notice that 3 is common in each of these lists. Now, the other thing is that when I looked at all these numbers, as I read them, I was like, okay, 15, 27, and 12, they all have a common factor of 3. I kind of just knew that. And then when I saw the 3 down at the bottom or on the side, because the largest number there is 3, because 3 went into all of those, the largest number here is 3, and so 3 had to be the greatest common factor out of that group. Okay, now let's look at the variables, okay? And so if I write all these out, x to the 5th, x to the 4th, x cubed, and then x squared. So if I do x to the 5th, it's multiplying x by itself 5 times. So I've got 1, 2, 3, 4, and 5. X to the 4th, I'm multiplying x 4 times. So 1, 2, 3, and 4. X cubed, I'm multiplying it 3 times. So 1, 2, and 3. And then x squared is just x times x, okay? And what's common with all of these is x squared, okay? 2 of them, all right? And so what I want to there's kind of a trick to this. And so the greatest common factor, so the GCF of variables, okay, is the variable with the smallest exponent. All right, and that's all I'm looking for. So when I just look at that list, I'm looking for the variable with the smallest exponent, and that's going to be my GCF, okay? So my greatest common factor here is x squared. Now when I put it all together, okay, because I have 3 and x squared, putting that all together is my greatest common factor as 3x squared, okay, out of that group, okay? All right, now let's take a look at the next list. Okay, and here we've got a number of numbers and variables. So what I want to do here is look at all of my numbers first, okay? I've got 14, -8, 2, and 4. Now, automatically, I just know that it's going to be 2, okay? Because the factors of 2 is just 2 and 1, all right? And 2 goes into all of these numbers because they're all even, okay? And so we don't have to always list those out, but let's just go ahead and do that. So for 14, I've got 1, 2, 7, and 14. For 8, I've got 1, 2, 4, and 8. All right, so even out of these two numbers, 2 is my largest common factor, all right? If I look at 4, that's just going to be 1, 2, and 4. 2 times 2 itself is going to give me 4. And then the factors of 2 is just 1 and 2. So out of that group, all right, 2 is my common number, all right? Now let's do all the ones with p's, okay? And so if we look at the terms of p, so p squared, p, and p cubed, okay, so let's get p cubed, p squared, and then p, all right? And so for this, I've got p times p times p, p squared, I've got p times p, and then for p, I've just got p. So remember that it's the one with the smallest exponent, all right? So they all have a common p in it, and so that's going to be my greatest common factor for all the p's. But now here's the part that's going to get really, really weird, okay? And that's the fact that if we look at all the ones with y's, y cubed, y squared, y, but this term has no y, okay? Because this term doesn't share a y, I can't find a greatest common factor that contains a y, all right? So because there's no y, then y is not included, so no y. So y is not included in the GCF, all right? So the only common thing that we can take out of here, okay, for this GCF is just going to be 2p, and that's my answer, and that's all we've got, okay? So not too terrible, okay, not too bad. All right, but now what I want to do is is talk about factoring. Once we've found the greatest common factor and we know what that is, okay, and it's pretty easy to do. It can take a little bit of time to explain what it all is, but what I want to do is talk about factoring and what we're really going to be doing. And what I like to call factoring, even though I wrote it up here as something that we multiply and we write numbers as the product of two numbers, okay? When I factor something, that's really the opposite of the distributive property, all right? And so let's just think of an example, all right? So if I just come in here and I say, all right, let's do, say, 3 times x plus, 5, okay? What I would do is I would distribute, okay? So this is, the one way that we go is distribute. So if I distribute this 3, I'm going to take 3 times x and 3 times 5 and add them together. So 3 times x plus 3 times 5, all right? And so that's going to give me 3x plus 15, okay? So this is distributing, all right? Now factoring means that you go backwards, okay? So let's write out 3x plus 15, and I want to factor, all right? And so, you know, what I would do here is I would say, all right, well, I've got 3 times x. All right, out of that term, I can rewrite that as that. And I want to write 15 as the product of two numbers. All right, and so I would put a plus 3 times 5. Now, what I'm doing here, I know I could factor this out to 1 times 15, but I want you to see that I have a common factor of 3. Okay, so my GCF is equal to 3. And what I would do is I would factor that out. I'm going to do the opposite of the distributive property, and I'm going to write that as 3. Take that 3 outside, put a parenthesis here, and what I would be left with would be x plus 5, all right? And so we get x plus 5, and that's my group, okay? And so this was what we started with. So this is the start of distributing, okay? Start of distributing, okay? And so, and that's kind of the idea, all right? So when we distribute, okay, that's something we've done in the past that's going one way. When I factor something, that means that we're going backwards, okay? And so we're kind of going in the circle, and you can kind of just keep doing that. So there's ways to check what you're doing here, okay? So what I want to do here is take a look at all these different examples, and I just want to factor those, all right? So let's first look at 3x plus 6. So if I look at the numbers 3 and 6, okay, my greatest common factor is going to be 3, all right? And so if I write this as 3 times x plus 3 times 2, okay, when I rewrite 6, I'm rewriting it as 3 times 2, okay. Now what I can do is I can factor out a common 3. All right, and you got to think about what you're left with. You're left with an x plus 2. All right, so when I do this, when I factor out my 3, then I'm just simply left with x plus 2, and that's that. And that's my answer, okay? Now, I can check what I'm doing, all right? I can check this by redistributing, okay? If I do 3 times x plus 2, if I distribute that 3, I'm going to do 3 times x plus 3 times 2, and 3 times x is just going to give me 3x, plus 3 times 2 is just going to give me 6, and that's what we started with, okay? So we're good, all right? So that's all we're doing. All right, now let's take a look over here on this one. All right, now this one's a little bit trickier. When I look at the numbers 2, 10, and 8, I know that my greatest common factor amongst them is just going to be a 2. Okay, and then when I look at my variables, I've got x cubed, x squared, and x. So my greatest common factor here is going to be 2x. So my GCF is equal to 2x. So when I do that, when I factor that out, and you kind of have to get good at doing this, you know, without having to rewrite it, if I factor out a 2x, look what I get. All right. When I know that that's my greatest common factor, I got to think about, all right, 2x times what is going to give me 2x cubed? And what's left is going to give me just simply an x squared. Okay? And then plus, all right, if I take out a 2x from 10x squared, I ask myself the question, 2x times what is going to give me 10x squared? And so 2 times 5, so put a plus 5 here, and then just a simple x. Okay? And then over on this last part, okay, taking out a 2x from here, 2x times what would give me 8x, and that's just going to give me a 4, okay? And that's it, okay? We are factored, okay? Now, what I have here, okay, to check, I can redistribute, all right? So if we wanted to check, then I'd be left with, let me write this out, 2x times x squared plus 5x plus 4. Okay, so I distribute that into each of those parts there, and so I've got 2x times x squared plus 2 times 5 times x plus 2 times 4 times x. Okay, so 2 times x squared is going to give me 2x cubed. 2 times 5 is 10, so 10, and then x squared, and then 2 times 4 is 8, and then times x, and that's what we started with here. All right, so I know that this is good. All right, let's take a look at the next one. All right, we've got 2 more here. All right, this one, okay, now we've already done this, okay, haven't we? On here, all right, if you look, 15x to the 5th, 12x to the 4th, 27x cubed, negative 3x squared. Our greatest common factor was already 3x squared. All right, so we don't have to do any work on that one necessarily, but let's just write this out, that our GCF is going to be 3x squared. All right, and so now if I factor that out, all right, from here, let me move this around. Okay, factor out my 3x squared. You have to think about what are you left with, all right? And so I ask myself the question, 3x squared times what is going to give me 15x to the 5th? So 3 times 15 is going to give me 5. So this is going to give me 5, and then this is going to give me an x cubed. Okay, over here, 3x squared times what is going to give me negative 12x to the 4th. So because that's negative, we've got to make sure that we put in a minus 4x squared. Okay, over here I've got a plus 9x. And then when I factor out a 3x squared from this negative 3x squared here, 3x squared times what is going to give me negative 3x squared? And that's just going to give me a minus 1. All right, and that's it. Okay, and that's all I'm doing for that. All right. Now, I can check it by remultiplying it in, but for time purposes, I'm just going to skip that, okay? All right, so now let's take a look over here. This one's a little bit trickier because we've got multiple variables. The first thing that I notice is that my coefficients 9, negative 15, and 3. Okay, 3 is my smallest number out of that, and the factors of that is just going to be 1 and 3. But 3 goes in to both 15 and 9. Okay, if I look at my terms with my x, okay, let me write this out here, that my GCF is 3 for that. If I look at my terms with the x, so x to the 4th, x squared, or I'm sorry, x cubed and then x squared, my variable with the smallest exponent is x squared. So I'm going to put that in there for my GCF. So this is going to be x squared. And then what I have, if I look at all these numbers, I've got y squared, y, and y. Now, because all of these terms have a y in them, I can factor out a y. All right, and so my ones with the smallest exponent is simply just going to give me a y. All right, so that's a y right there. All right, so that's my greatest common factor. All right, so once I factor that out, all right, and I'm going to write this as 3x squared y, then I am left with, we've got to think. All right, so 3 times what is going to give me 9? That's going to give me a 3. Okay, x squared times what is going to give me x to the 4th? And that's going to give me x squared. All right. And then y times what is going to give me y squared, and that's just going to give me a y. All right. Now, on this next term, 3 times what gives me negative 15? That's going to give me negative 5. X squared times what gives me x cubed? This is going to give me an x. And then y times what gives me y, and that's just a 1. Okay, and I don't need to put that in there. All right. And so then let's add that to 3x squared y, which is this entire term here. So 3x squared y times what is going to give me 3x squared y, and that's simply just going to give me a positive 1. All right, and that is my factored form. All right, so not too terrible, but just remember that you can, check yourself by multiplying, all right, and all that. So let's go ahead and jump down into here to factor by grouping. Now, what I want to do here is is look at this. Now this is just it looks like just a bunch of just gibberish, all right? So what I want to look at is that this whole thing here is a term itself. And this whole thing is a term itself. And that's because I have parentheses, all right? So the parentheses, when you group something like that and then you multiply, this whole thing is a term. Okay, so when I look at this whole term here and this whole term here, then you got to think about what you're left with, all right? Well, let's just think about what's in common. Okay, the common thing that I see is an x plus 1. Okay, now if I were to factor out an x plus 1, you have to think about what are you left with, which is the x squared and then plus 2. All right, so you're left with then x squared plus 2. And that's it, all right? And that's all we're doing on that, okay? Let's take a look over on this one. If I look at this term, what's common in this first term is an x plus 7. And over in this term is an x plus 7. So if I factor out an x plus 7, then I am left with x squared and a 3. So I'm just going to write this as x squared and then plus 3, and then that's my answer. Okay, on this last one, all right, what's common here is an a plus b, all right? That's common here, and it's common here. If I factor out an a plus b, then I'm left with x cubed minus 5, okay? Now, the question is, you're probably wondering, okay, what is going on here? Why are we doing this? All right, what I want to do is think of an example, all right, and let's do this. Let me come in here and let's write out an example. Okay, so make sure you got some room for this. What I want to do is I want to factor by grouping, okay? And so what I want to do here is I'm going to do, let's just say I have the polynomial x cubed plus 3x squared plus 2x and then plus 6, okay? What I want to do to factor something like this is to group it. So I'm going to group these first two terms and then these last two terms. And I want to think about what could I factor out of these two terms, or this term here, of these this group. Okay, so I don't have any numbers out here, so I can factor out a 1, but then I've got a common x squared. So out here I can factor out an x squared out of this. Okay, and I'm left with x and then plus, or I'm sorry, x squared, or I'm sorry, factor out an x squared, okay, and then you're left with x and then plus 3. Okay, in this group here, I can factor out a 2. All right, so I'm going to do a plus 2, and then I'm left with x plus 3. Okay, and that's where we get to this point here. All right, so what we did on this was we skipped this initial first step of using a 4-term polynomial, usually starting with an x cubed, and then getting down to this point here. All right, so now what I have in each of these factors is a common x plus 3. All right, so if I factor out an x plus 3, then I'm left with an x squared and a plus 2, and I simply just write x squared plus 2. Now, the way to check yourself with this is to multiply this out, okay? And so if I were to do, say, the box method on this and multiply this out, what we learned previously, I'm going to do x plus 3 and then x squared plus 2. So if I do x squared times x, that's going to give me x cubed. All right, and then if I do x squared times 3, that's going to give me plus 3x squared. Okay, and so on this one, x times 2 is going to give me 2x. And then I've got 2 times 3, which is going to give me a positive 6. Okay, so when I add all these together, I'm going to get x cubed plus 3x squared plus 2x and then plus 6. All right, and that is what I started with up here. All right, and so we're going to move, on the next section, we're going to do a lot of this where we take something like this. Take a polynomial, and we're going to factor it as the product of two binomials, all right? And, the other thing I want to say about this is noticing that this quantity is something that you factor out, okay? And that's kind of the jump that we have to make in this class in order to be successful. I think that all of these problems here are pretty self-explanatory when it comes to factoring, but when you all of a sudden throw in this quantity here and you factor that out, then it can get really confusing, okay, from what I've noticed in the past. And so whenever you have this, just realize that, what I'm doing here is really no different than what I was doing here, except for now I'm dealing with an algebraic expression as opposed to a number. All right, so I'm essentially doing the same thing, just a little bit different, and adding to that idea. So go ahead, and when you guys do your homework, okay, I want to change this up, okay? On your homework, I don't want you to do 49 through 61 odd. This is optional. You can do it if you want, all right? But instead of that, I just want you guys to do 1 through 47 odd, okay? And that's all I want you guys to do. If you want to make that jump and do 49 through 61 odd, you can, but I'm not requiring it. And that's all I got, okay? So it is a little bit brand new, it is a little bit tricky, but there are, make sure that if you're confused, you go back and rewatch this video and come on to office hours. So we'll see you soon. Thanks a lot. Bye.